Hi guys, and welcome to this my video on solving linear equations and developing formula, part of the Year 11 General Maths course, but basically universal. I mean, you don't need to be here in Australia to be able to do this stuff, because I am going to smash you through and help you do really well. My name's Darren from Maths Guru. You're going to say, huh? And I'm going to say mathsguru.com. A website that is devoted to making maths so much easier for you. It's my little world of the internet, or my little part of the internet. Hopefully you'll go over there, because they've got downloadable lesson notes, time codes, exam questions, and so much more coming on. The only thing I'm going to ask you to do, if you would be so kind, is just subscribe to YouTube. Why? Because it just lets me know that someone out there is watching and I'm not talking to myself like a complete lunatic. Right? Every time someone subscribes, it just gives me that little bit of a buzz to say, yes, keep going, keep going, keep going. Someone out there is getting help from my videos. Now, learning objectives, I would normally go through these, but basically if you need to, just pause the video. They are there to tell you what I'm effectively going to cover. Now, we've done a lot in previous years, but I've not explained stuff to you like I have done. Now, I've got a very unique way of doing it, all right? Most of the stuff I probably cannot put online. I'll try, but we'll wait and see. But long story short, I tend to deal with things like algebra, and everyone goes, algebra, don't shudder, it's fine, all right? Trust me. But I tend to deal with things like kissy kissies and bunk beds and prison guards and so much more. So I may well intersperse these videos with stories. It's just meant to make you laugh, but to get into your head the general idea that maths can be fun and it can be humorous, and the stories put things into your head. Right, now, unpacking is the way to go. I have vowed I am never ever moving house again. I'm not putting stuff in a box to move them to unbox it again. It's almost soul destroying, like when you go shopping, isn't it? You go, you put it in the trolley, you pack the trolley, you put it in the car, you bring it home, you unpack it again. Soul destroying. But unpacking is the way to go. And I think of things as I want to make the letter the loner. All right, I'm a bit of a loner in life. I'm sorry to say that. No, proud, own it. But the point of it is I get very shy when anyone walks up to me and goes, Maths Guru, and I go, oh, because I don't think anyone watches these videos. So if ever you do see me, come up and say hello, and I'll just go, but that's not personal. It's just me. I get very nervous. But the point of it is a loner. All right, I'm trying to make the letter on its own. And if you can do that and reverse stuff, life is really good. Now, you need to know the opposite of sign. So as I say here, if you've got a plus, the opposite is a minus. When I'm adding on and I want to undo it, I'm going to take away. Likewise, a negative and a positive are opposite. So if I'm taking something away, I can get rid of it by adding the same thing on. Times and divide are opposite each other. And then we'll sort of come to square and square roots and what have a little bit later on. But just knowing those basic reverses is the same. So here we go. This is what I tend to start with. So x plus 6 equals 10. So the first thing I want to do is I identify the pronumeral or the letter, and I go, well, there you go. Hello, pronumeral. How are you doing? And they go, I'm well, thank you. And then I worry that I'm talking to a letter, an inanimate object, but I do it all the time. So that is what I want to leave on its own. What's connected to it? What's stuck to it? What's by it? Well, in this situation, it is the plus 6. Well, I don't want a plus 6 there. I want to get rid of it. I'm going to unpack it. I'm going to get rid of it. Bye-bye. How do I undo a plus 6? Well, I take away 6 from both sides. And with algebra, what you do to one side, you have to do to the other. Now, again, I'm a very visual learner. And a lot of the boys I teach are like, yeah, you're not doing it. It's too hard. Don't want to write all that. It's pointless. Well, write it, because your brain is visual. The more you do it, the more you'll be like, yeah, I've got this, I'm done, all right? You may do this for 10 or 15 examples before you go, yeah, I've got it now, it's fine. But that means it's in your brain. Anyway, so by taking away 6 from both sides, that now disappears, leaving me with just the x. But I've got to take away 6 from this side as well. So 10 minus 6 gives me 4. The letter is now on its own. Life is awesome. And you're going to say that was ridiculously simple. And you're also going to say, well, I could have done that in my head. Yes, you could have done. But with general maths and exams, you've generally got to show some sort of working out. And then ultimately in that situation, that would be my working out. The next one, I've got 3y is equal to 18. So I want to get the letter on its own. Now, this is where I come to the whole kissy things, because when I do a card to my mum or dad, I say, dear mum, love you, Darren. And then I put all these down, but you know, and I was like, oh my goodness, I didn't know, but that's maths. And you're going to go, no, it's kisses. And I'm going, no, it isn't, because it looks like time signs. Whenever I've signed off my card to my mum, I'm putting time signs on. Yeah, no, I need to write my medication. So what I think of a time sign is a kissy. So between that 3 and the y, there's a kissy. they're kissing. Swapping bronchitis. Leave that one there. Now I'm feeling unwell. But the point of it is I want to break up the kissing couple. So if there, and I'm writing it out longhand, if there's a 3 times y there, and I want the letter to be on its own, I've got to lose the 3 and the times. Well, how do I undo a 3 times or a times by 3? Well, hopefully I'm going to divide both sides by 3. Now again, by doing that, that times by 3 disappears. It's gone. That's the whole point of doing it. And so I get y is equal to, I've still got to do the 18 divided by 3, and that gives me 6. And you're going to turn around and say, but I could have done that in my head. I know you could have done. These are ridiculously basic questions that are ultimately scaffolding the harder stuff to come. Let's look at this. And again, here we go. We've got a harder question now. So we got 4 brackets x minus 3 equals 24. Now there are 2 ways of doing this. So what I'm actually going to do is I'm going to lasso this and move it over. And let's see whether we can do it in both ways. Now, many of you from previous year levels will probably be told to multiply up the brackets. So you would do 4 times x and 4 times minus 3. That certainly works, and let's do that now. Now, 4 times x is 4x. 4 times minus 3 is minus 12, and that's going to give me 24. Now, I've now got a loner in there, but they're kissing with somebody watching. Yeah, that's a bit awkward. So that's like me when Saul and his girlfriend Cheryl at the time used to go to the cinema. They'd be sitting there holding hands very lovely-dovely. I'd be the gooseberry. I'd be like the weirdo sitting beside them. And I'd be like, no, this is awkward. Nah, didn't have a girlfriend. That's fine. I'm dealing with it in therapy. But the point of it is, what I now say is, right, well, wherever there's a kissing couple, I'll leave them till the very end. Let's not split them up until the very end. Let's them do what they need to do. But the point of it is, so that means I've got to get rid of this take away 12. How do I undo a take away 12? Oh, I add 12 to both sides. And again, that is now gone. That's why I'm doing it. Leaving me with 4x is equal to 24 plus 12, 36. Now I'm going to break up the kissing couple, right? And again, they're kissing, so that's 4 times x equals 36. What do I want to get rid of? Well, I want the letter on its own. I want the letter to be a loser, and so, or a loner, and so I've got to get rid of that 4 times. How do I get rid of a times by 4? Oh my goodness, I would divide both sides by 4. So there we go. So I'm going to divide by 4, and I'm going to divide by 4 again. That now gets rid of this, leaving me with nothing more but the x on its own, and 36 divided by 4 is going to give me 9. Ka-ching, and there we go. And that's certainly one way of doing it. There is another way of doing it. So if I now do 4x minus 3 equals 24, I can think of this as 4 times whatever in that brackets. I can't get to the brackets. I can't get to what's inside the brackets until I get rid of this 4. But that's a times by 4. The 4 is kissing, and I think of that as a prison guard. A whole new discussion. Now again, so in that situation, if I was to write that as 4 times x minus 3 equals 24, well, how do I get rid of a times by 4? How am I going to release the brackets? I've got to get rid of what's outside. Well, yeah, I'm going to divide everything by 4. So if I divide everything by 4, and again, I have to do both sides, that's gone, leaving me with x minus 3. And I don't need the brackets anymore because that 4 times outside is gone. The brackets can now open. And 24 divided by 4 is going to give me 4, 8, 12, 16, 20, 24. Yes, I use my fingers. 6. Hold on a moment. My letter, and are they kissing? There is not kissing. So in this situation, I want to get rid of a minus 3. How am I going to get rid of that minus 3? I'm going to add 3 to both sides. So in which case, that minus 3 now disappears, leaving me with x. And 6 plus 3 is 9. And what we found is, yes, well, hopefully it's the same answer. Which did you prefer? There's no right way of doing it. It's just a way of doing it. And there we go. So you can choose, but again, don't get tricked. What about this one? Now, the great thing is we can use our CAS calculator. And again, there are lots of ways of doing this question. I'll show you a different way in just a moment. But if you are using your TI Inspire or your ClassPad, and this is a CAS-enabled course, so you should be able to use a calculator, we can literally use our solve function, which I think is menu 3.1. Actually, let's bring up my calculator. Let's delete what was on there before. And let's see, whether it's menu 3.1. There we go. So you have your solve function and you just type it in. You go -4, -5 times b. And my advice is to always put in the times is equals to 8. Now, if you don't know where the equal sign, it's just below the control key here. All right, so there's my equal sign is equal to, what does it say, 8. And you put a comma and an X. The reason you're doing the comma and the X is to tell the calculator that's what you're trying to find. The calculator is a dumb piece of machinery. It doesn't really understand what is going on. And you'll notice there that my calculator seems to have done things a little bit differently. I wonder why. Well, I'm going to come back to that one a bit later on because I don't know at the moment. But the first time I did this, I got my value of B was equal to minus 12 on 5. All right, and again, if you wanted that as a decimal, there's lots of things you can do on your calculator to be able to do that. But it can also be done by hand. How can it be done by hand? Well, minus 4 minus 5b equals 8. I do not like minus signs. Remember, we are trying to get the b on its own. And stuck in front of that b is a minus 5. I don't want it to be a minus. I like positive numbers, please. So we can employ a bit of a trick. When our pronumeral or a coefficient of our pronumeral is negative, I actually multiply everything by minus 1. And you're going to say, well, what does that do? It swaps the signs of absolutely everything. So where I have a minus 4, I'm going to swap the sign. That's going to become a plus 4. Where I have a minus 5b, that's going to become plus 5b. And again, because I have to do every term, where that was a plus 8, that's now going to become a minus 8. And as far as I'm concerned, that now looks a lot nicer. Right, so what am I going to get rid of first? The plus 5? No, because the plus 5 and the b are kissing, so leave them alone, which means I've got to get rid of this 4, which is really a positive 4. And how do I undo a positive 4? I'm going to subtract 4 from both sides. That is now going to disappear, leaving me with the plus 5b equals, and minus 8 minus 4 is going to give me minus 12. I've got now the kissing couple. There is 5 times b is equal to minus 12. What do I want to get rid of? Well, I want the b on its own, so I've got to get rid of the times by 5. So I'm going to divide both sides by 5. So the b is equal to minus 12 divided by 5, which I'm pretty sure my calculator got a little bit ago. Happy with that? Me too. Practice makes perfect. The more you do of these, the better. Right, find an equation for the perimeter of the triangle shown. Again, there are lots and lots of different questions what we can throw at you, and we can build on stuff. But what is the perimeter of a shape? That's right, it's all the way around the edge. So I tend to start at a point, and I'm going to go that value plus that value plus that value. Right, so what does it say? Find an equation for the perimeter. An equation has to have an equal sign. So P equals, and again, I'm going to start at one corner and go up. So that's 4 plus that distance there, which is x, plus that distance there is 7. Now, I could leave it like that, but you've got to collect like terms. There are things that we can actually join together. We can do 4 plus 7. So in which case we know that 4 plus 7 is 11 plus x. And that is certainly an answer. But I imagine if I looked at this in the textbook, for example, they would write it as p is equal to x plus 11. The reason being they've effectively taken the terms and swapped them over. We can do that. We generally start with the x term first. We just need to know that in front of the x is a plus, and in front of the x has to stay a plus. In front of the 11 is a plus. In front of the 11 there must make a plus. I know lots of people make silly mistakes. So for example, if I had 2 minus x, they think that's the same as x minus 2. They've just swapped the x here and the 2 here. That's not true. That minus sign belongs to the x. So if I was going to do that properly, then it would be minus x, he says writing in highlighter, plus 2. Because in front of the 2 is a plus, so in front of the 2 must stay a plus, right? So these are the tricks that we tend to use in our teaching. Here's another example. Worded problems. Don't you hate worded problems? Because they just mess with your head. Okay, that's fine. Again, practice. These are very hard to teach. If 11 is added to a certain number, they've said a certain number. I don't know what the number is. Could I use a letter to stand for that? I could. So if 11 is added to a certain number, so I'm going to say 11 is added to a certain number. The result is, well, again, that's basically English for equals 25. Oh, cool. There we go. Find the number. So in this situation, we're going to find the value of x. Is anything stuck to it with a kissy kissy? Nope. Something is stuck to it with the 11. So basically in this situation, we've got a plus 11 there. So I'm going to undo it. by taking 11 away from both sides. And again, a lot of people go, but I can do that in my head. 11 plus something is 25. I know what the answer is. I know, but I'm still showing the process. So that leaves x on its own. 25 minus 11 is 14. Ka-ching, there is my answer. Again, fairly simple. And if you're watching this going, these examples are not difficult. No, they're not difficult. They're not meant to be difficult. They're there to actually try and help. At a recent show, Chris spends $100 on 8 show bags, each costing the same price. Use X as the cost of one show bag. So X is one show bag. Write an equation showing the cost of 8 show bags. Now, obviously, I've done here my example on there, but X is the cost of one show bag. I'm buying 8. So I must be multiplying that by 8. So that multiplied by 8 is equal to, because it tells me how much I've spent, $100. Now, again, normally when things are kissy-kissy, we write the numbers and then alphabetical order. So that would be 8. X is equal to 100. What do I do now? Well, I can either divide both sides by 8. And you're going to say, whoa, why? Well, again, remember, what's between the 8 and the X? A times sign. So how do I undo an 8 times? Well, I move it to the other side and it becomes a divide by 8. And in that situation, as you can see, the calculator trying to be clever gives me 25 on 2. Or if I get my calculator to write it as a decimal number, gives me 12.5. Now, again, a word of warning, guys, that is not a correct answer. Right? The question basically wants to say, find the equation or use an equation to find the cost of a show bag. 12.5 is not money. It's not a cost. So in which case you would have to write, therefore, the cost is equal to, with my dollar sign, 12.5. Yes? No. Again, money is always to 2 decimal places. Your calculator doesn't know what you're dealing with. And so you would have to write the 0 on the end there as well. Again, these are all silly things that are designed really to trip you up. A car rental company has a fixed charge of $110 per day plus $84 per day for the hire of a car. Now, again, if you don't understand the context of the question, it becomes really challenging. If you've never hired a car or even taken a cab, but basically, when you get into a taxi or a cab, what do? You pay a flat fee. You're going to pay that fee whether the cab moves or not. And then they add on a variable fee, something depending on the mileage you're going to do. So the Brown family have budgeted $650 for the hire of a car during the family holiday. How many days can they hire a car? Well, the first thing I'm going to say is the cost of hiring a car is, there's a fixed charge. That's $110 plus $84 per day. So that's the variable stuff. So I'm going to do 84 times, well, what letter should we use? Probably D for day. So that there is a formula that tells me how much my car is going to cost for any number of days. It says the family have budgeted $650 for the hire of a car, so they're paying $650. So that $650 is equal to 110 plus 84 times D, right? For how many days can they hire a car? Now, I'm actually looking at this going, I have no idea what that screenshot has anything to do with. It must be a different example a little bit later on. Yes? Let's see. Now, I could have put that straight into my calculator, and I'll do that in just a moment. But what I think I've done here is I've said, well, how do I get rid of the D? How do I get rid of that value there? Well, I'm going to take away $110 from both sides. So I get 540 is equal to 84 times D. Let's see how far that goes. So I put that into my calculator as a solve. So I've done solve, brackets, 84D equals 540, comma D. And again, it doesn't matter if you swap them around, so long as they actually, the equation is the same. Now, when my value of D came out on my calculator, I got 6.428 ... I'm not going to write that. No car hire company is going to allow you to rent a car for 6.42857142857 days. They're going to either give it to you 6 days or 7 days. And so what do you think the trick to the question is? Well, if I actually hire it for 7 days, it's going to actually cost too much. Right? So if you think about it, 7 days is going to cost me $110 plus 7 lots of 84. That's going to be too much. So this is actually a question trying to work out whether you know how to round appropriately. So in this situation, they only have enough for 6 days. And believe it or not, that is the end of this video. Hopefully it has been useful. There are other more complicated questions that I'm going to do in another video. I'll do a bit of a recap at the next video that looks at some division questions because I think of them as bunk beds, and there's a bit of a story behind that as well. But hopefully this has been useful. It's 20 minutes long. I know that's fairly long, but the principles behind this sort of underpin the rest of the course. If you can subscribe to my YouTube channel, please head over there. Let me know you're watching, and hopefully I'll see you in other videos. Tell your mates, tell your teachers. I look forward to seeing you again. Take care. Bye-bye.